Hello, grade 11. In this lecture, I'm going to make a summary for the whole steps that are needed in order to study the polynomial functions. So first of all, the plan of studying a polynomial function needs several steps. The first step is to set or define the domain of definition of the function, or in another word, the interval of the function. Where does it start and where does it end? So the first thing we do is domain of definition. In polynomial functions, most polynomial functions, their domain of definition is minus infinity to plus infinity or real numbers, unless they define for you a specific interval, for example from -4 to 4 or whatever it is. But if you are asked to find the domain of definition of a function, of a polynomial function, then it's minus infinity to plus infinity. After the domain of definition, we need to tell if the function is even or odd, or to study the parity of a function. What does the parity helps me in? If the function is even, then it has an axis of symmetry. Then no need to draw the whole graph. You can only draw a part of the graph according to the table of variation or the table of points, and you can continue the graph according to its symmetry to y prime y if it's an even function, or according to the center of symmetry if it's an odd function. So what does the parity helps me in? Helps me to draw part of the graph according to points or whatever table of variation is, and to continue the graph according to the symmetry. The third thing we do is to find the limits on the open intervals. So if the domain of definition is from minus infinity to plus infinity, so you study the limits at minus infinity and at plus infinity. So domain of definition, parity, limits. After the limits, we have to find the derivative and study its sign. Just to make a quick revision, if the derivative is negative, then the function is decreasing. If the derivative is positive, then the function is increasing. So the derivative itself helps me in studying the sign of the function. That's why we calculate the derivative, then we study the sign of the derivative, because the sign of the derivative tells me the sense of variation of the function. And sometimes we can have extremums, means maximum or minimum. It depends if we have roots for the derivative when we are studying the sign. Now I'm just talking in general about the steps. Later on in the coming slides, I will give a lot of examples. After all that, the domain, the limits, the derivative, we need to do a table of variation. In the table of variation, we put everything we need, starting from the domain, limits, extremum. So we all put them in a table of variation, and after the table of variation, we can have some points if needed to draw the curve. So 6 important steps to draw the curve or to study the polynomial function. Let us take an example. Here we have the function x squared plus 4x minus 1. As I told you before, the domain of definition of any polynomial function is R, which is from minus infinity to plus infinity. After finding the domain of definition, I told you to find the parity of the function. So we are going to tell if it's even or odd. Let us start with the limit now at open intervals. So we need to do the limit at minus infinity and limit at plus infinity. If we do the limit at minus infinity, then it's the limit of the highest degree, which is x squared. Limit when x tends to minus infinity is plus infinity, because minus infinity squared is plus infinity. Now limit when x tends to plus infinity is plus infinity. We are done from the limit. Now we are going to do the derivative and study the sign. The derivative of x squared plus 4x minus 1 is 2x plus 4. Now we have to study sign of the derivative, so we need to take the derivative equals to 0. 2x plus 4 equals to 0, 2x equals minus 4, x equals minus 2. So we have a root, we put it on here, we just study the sign of the derivative. So we have minus 2, opposite, same. A is positive, the sign of x is positive, so minus plus, this is the derivative. Now, so we did the domain of definition, the limits, the derivative, and now study sign, and now we are going to do the table of variation. So in the table of variation, we put from minus infinity to plus infinity the domain of definition. We put the minus 2, which is the root of the derivative. So here we have minus and plus, as we told before. As I told you, if the derivative is negative, then the function is decreasing, and if the derivative is positive, then the function is increasing. And how do we find this value? We replace x by minus 2 in the function itself, not the derivative, because if you replace f of minus 2 in the f prime of minus 2, it's 0, it's a root. So we replace it in f of x, it's minus 5. So if I want to summarize this table, the function is decreasing from positive infinity to a point which is minus 2, minus 5, then it's increasing to plus infinity. This is the table of variation. So now I need to draw the curve. So here the function is decreasing to minus 2, minus 5, then it's increasing, right? But I need to have these particular points to tell exactly, because sometimes you may tell me, for example, that it's like this or like this. So how do I make sure that the function it's 100% true? I need to take points. These points are the points of intersection of the curve with the x prime or x. The point of intersection of the curve with x prime or x is for y equals to 0, right? Because no coordinates on y. So for y equals to 0, then we have two particular points. This is a point and this is the point. We plot them on the curve. Now I need to know the curve with the y prime or y. So it's x equals to 0, it's y equal minus 1. So I plot all of these points just to make the curve exactly correct. Okay? Now we'll take another example. We have minus x squared plus 4. Also, this is a polynomial. So the domain of definition is minus infinity plus infinity. Here they studied the parity. The function is even, because f of minus x, it's the same as f of x, so it admits y prime or y as an axis of symmetry. Pay attention to this very well. I'm going to highlight it for you. So admits y prime or y as an axis of symmetry, because in the curve you will see how does the y prime or y affect our curve. Now we're going to do the limit. So limit of f of x when x tends to plus infinity is minus infinity, and the limit when x tends to minus infinity is, sorry, let us go back. Okay, now we're going to do the derivative. F prime of this function is minus 2x. Minus 2x equals to 0. We have a point which is 0. Okay, so from 0 to plus infinity, it's decreasing. So we're going to do, oh, they only want you to do from 0 to plus infinity, so they split it for you the interval. Why? Because it's an even function, so it's enough to draw a part of the curve because it's asymmetric. Look here, this is from, do you still remember when I told you that y prime y is an axis of symmetry? So this part of the curve is exactly as this part of the curve. Okay, so that's why we do the parity, because it helps us in the curve and drawing the curve. And now we're going to take the third example. We have x cubed minus 3x squared plus 2. Also, this is a polynomial, so the domain of definition is from minus infinity to plus infinity. Now we're going to do the limit at open boundaries. Limit for f of x when x tends to minus infinity is minus infinity, and limit of f of x when x tends to plus infinity is plus infinity. Now we're going to do the derivative. The derivative of x cubed minus 3x squared plus 2 is 3x squared minus 6x. So now we're going to take to do the study sign. So the derivative is equal to 0. So we have here two roots, okay, 0 and 2. Both of them are roots for the derivative. So inside the root opposite sign of a, if you still remember the first lesson, do you still remember when I told you the first lesson will help us in many lessons? So that's why we took inside the roots opposite sign of a, so plus minus a plus. And now we're going to do the variation. In the table of variation, we're going to put the domain, which is from minus infinity to plus infinity, the two roots 0 and 2, plus minus plus. The derivative is positive, so the function is increasing. The derivative is negative, then the function is decreasing. And the derivative is positive, so the function is again increasing. We do at minus infinity we got minus infinity, at plus infinity we got plus infinity. So the function is increasing from minus infinity to a point which is 0, 2, then it's decreasing to a point which is 2 minus 2, and then it's increasing to plus infinity. So when drawing the curve, these are the two important points: 0, 2, which is the maximum, 0 minus 2, 2 minus 2, which is the minimum. It's increasing, decreasing, increasing, but we still need to know these points because they are very important. They are on the x-axis, so we take y equals to 0. When taking y equals to 0, we're going to have 3 points, 3 roots, 1 minus radical 3, and 1 plus radical 3. So these are the 3 points which are the point of intersection of the curve with x prime or x, and now we can draw the curve immediately. Okay, so I wish you got this clear. In the coming lecture, I'm going to make a whole steps also for the rational functions. When I say rational functions, I mean the functions that are fractions, and we're going to do all the steps needed and all the examples needed in order to make the variation easy for you. Okay.